When somebody tells you that their hotend can reach 500 degrees Celsius and their extruder has kind of hot swappable hotends, you can only really be interested. But we never actually found out if it's any good. So grab a cup of tea and let's find out. Hello everyone, my name's Adam and welcome back to the channel. Today we're taking a look at this, the Dyze Extruder Pro and Dyze End Pro from Dyze Design, an engineering outfit based in Montreal, Canada. What I have here is the Pro kit, if you like, so that comes with the extruder, the hotend, and I've selected it to be in 24 volts with a 500 degrees C thermostat. It comes with a 0.4mm nozzle, and I also have a 0.6 and 0.9 nozzle to test out as well, but those are separate to the base kit. I've got it all set up on my Ender 3. I switched out the control board for an MKS base, but otherwise basically the same. I created a little adapter plate to be able to mount this extruder and hotend to the standard carriage, and I've set it up in a direct drive system rather than the original Bowden. It can do a Bowden setup if that's what you want to do, but for me, direct drive was the way forwards. By the way, I do know that a £150 printer is not necessarily the intended use case or market for a £250 extruder and hotend. However, that's the printer I had available, so that's what we're using to test. Now that that's all out of the way, we can get on with the review. We'll start with the hotend, first looking at the setup and getting started, if you like. The physical assembly of the hotend is really quite simple. There's not much you have to do. Just insert the thermostat and heater cartridge and you're pretty much good to go. The rest of it all comes pre-assembled. So there's no like heating it up and having to tighten it when hot and all that kind of stuff. It's just ready to go. I mean, even if it wasn't ready to go, because of the design of this hotend and you have cold swappable nozzles and that sort of thing, you don't actually need to do any preheat or heating up to do the tightening or anything like that. So even if it wasn't assembled, it would still be quite easy. Talking of quickly removable nozzles, let's have a look at the kind of hot swapping features, or ironically cold swapping features of this kit. So there's two things that you can swap more easily than normal. That is the hotend, the entire thing, and also the nozzle itself. So the hotend is a kind of a latch at the bottom of the extruder, and you can undo that and the whole hotend assembly comes out. And then of course you've got your wires, and they just have some connectors up here that you just need to disconnect. They're all locking connectors, which is really good, and they all seem to be well rated for the currents and voltages that they're being used for. So again, really good. The cold swappable nozzles is really quite easy to do. Obviously once you've got the hotend out, you just need a couple of spanners of the right size and then just twist it out. It does take a little bit more force than you'll probably be initially comfortable with, but you got kind of working against a tungsten carbide nozzle and a steel block, so there's not really any risk of damaging stuff too much. Just make sure you have the right spanners and not some weird mildly adjustable thing or anything made of plastic. Just use the right tools and it'll come out really not too difficultly, not too hard. It won't be that difficult. The one slight downside, if you like, of the cold swappable nozzles is, I suppose, not necessarily a downside of the feature itself, but the easiest way to do it is to make sure that the filament has been removed from the hotend. But obviously in order to remove the filament, you need to heat it up. So it's worth maybe considering when you're going to do that nozzle swap and if it's worth removing the filament at the end of your last print. Otherwise you're going to have to heat it up to take the filament out and then let it cool down again before you can remove it and work with it. I mean, you could probably do it hot, but it's a bit of a risk to burn your hands, so maybe not the best. But the actual feature itself does work really well. I've done it a couple of times and I'm pretty happy with it. Looking at heating and control systems, we've got a 24 volt 60 watt heater cartridge. That, for reference, the E3D-V6 is a 30 watt heater cartridge, so you've got double the heating power, which is a lot of power. In fact, it does make PID tuning quite difficult because it's so powerful that it just tends to overshoot and then fail the calibration. No matter what I did to change the settings that were recommended by Dyze Design, it did seem to still fail that PID tune unless I reduced the maximum power output of the heater cartridge. I think I ended up reducing it by about 40%, which, I mean, it is still a lot of wattage, so it's going to be fine for this kind of size block and this kind of size nozzle. So I'm not too worried there, but it does seem a little bit overpowered for the current kind of PID control system and this size block. However, if you're printing with super high temperature materials near the 500 degrees Celsius, you're going to be thankful that you've got a 60 watt heater. With that all being said, the control system does handle it well. It is very stable when it's at temperature. It's just a little bit shaky getting there in the first place. Another slight downside of the control system is that the thermostat, being suited for 500 degrees Celsius, is quite inaccurate at low temperatures, which means you can quite often get a heating error as you're trying to heat up because it's not sure whether it's at 20 degrees or 50 degrees. So it gets a bit shaky, but as it gets up to kind of 70 or 80 towards 100 degrees, it gets much better and then you don't have any problems. There are some changes in Marlin firmware that you will need to make in order to run this kind of thermostat, and those are all explained quite nicely in the guide for the setup. If you do print sometimes at cold temperatures and sometimes at high temperatures, then you're probably going to want different PID values for those different temperatures. I mean, normally we just set them for in the range of like 200 to 260 degrees Celsius, but because the control range is so broad, 200 to 500, you do need slightly different values for those two settings. You can change those with G-code, so if you do print in the very largest range of temperatures, then you can switch your PID values for different materials that you want to print. The 12 volt version of this heater cartridge is only 45 watts. So that got me thinking, if they can both do 500 degrees Celsius, why is the 12 volt one lower wattage than the 60 watt? The 12 volt one lower than the 24 volt one? So I decided to ask the CTO, Felipe, at Dyze Design, to see what he had to say about that difference in wattage. It's mostly a manufacturing problem. At 12 volts, the current gets pretty high and the wire inside the heater can be easily damaged if the power gets too high. 45 watts is the limit suggested by a supplier for a reliable mean time between failure and low waste rate. Speaking of the thermostat, I do quite like the design. It's nice and easy to put in with very low risk of damage because you don't have to kind of crush it a little bit with a screw. It has its own thread and just screws into the heat block. The downside is perhaps it doesn't achieve as great thermal contact to the steel block, which may be why, one of the other problems, it tends to read about 10 degrees hotter than it actually is. So maybe that could be a factor, I'm not totally sure. It's not really a problem, you can just slightly adjust your temperature settings. You're likely to get different temperatures between different printers anyway, so just bear in mind that this one tends to read slightly hotter than it actually is. No, tends to read slightly colder than it actually is. It's normally hotter than what it says, if that makes sense. Hopefully, yeah. When it says 230, it's probably around the 240 region. Talking about cooling recently, you've obviously got two fans here. You've got the part cooling fan and the cold end fan. So the cold end fan is unfortunately quite noisy. It's quite small, I think it's a 25 or 30 millimeter fan, a bit like the E3D V6 one, and as a result, it is a bit of a noisy little fan. I mean, it's not that bad, it's not quite as loud as the V6, but it is quite noisy. Again, I did ask Felipe about this because given the history of loud fans and the move towards quieter printers, it did seem like an interesting choice. And his answer was, it was mostly to reduce the overall size. It was a very early decision, and now that I've realised that everybody hates these fans, I would have done it differently. So there you go. They generally agree. Unfortunately, it's what we've got. However, it does work well, so it's not really a problem as such, it's just a little bit noisier than you might like. That's it for the heating and control system, so let's have a look at the printing capability of the Hotend. It's worth bearing in mind here that I didn't spend hours and hours tuning in printer profiles for loads of different materials. I just don't think that's really worth it for a review of a Hotend. We're looking at the technical aspects and whether it's capable of doing certain things. If the settings mean I can do something too low and something too high, then it just is time before you find the right value in the middle. During all my testing, a lot of it you can see here, I did print a variety of different materials, including ABS, PETG, PLA, hips, carbon field hips that is, also carbon field hips, more PLA. I did print another carbon field material, but I don't seem to have, I think this might be, this like a carbon field PETG, more PLA, hips again. To test flexibles, I did also print TPU. I mean, I've never really used any flexibles ever before, so I just did something really basic just to make sure it works, and it does. It looks really, really nice, actually. While I didn't do something with loads of extreme retractions and that to really, really push the capability of the flexibles, when you take a look at the inside of this extruder and how constrained that filament path is, you really shouldn't be concerned about being able to push flexibles through it. The most difficult material to print here was actually PLA, especially to make it look good. It's just a lot of heat into the part, and PLA likes to be nice and cool. So I think that's largely because the cooling solution is not very great, and we'll talk about that in a bit. But we did get a bit of stringing and it just didn't end up looking that great. I did tune in the profiles a little bit more and it is improved somewhat, so Yes, you could get good PLA prints out of it, but I don't think that's really, honestly, that important for this kind of hot end. ABS and PETG were quite stringy, especially at the start. Again, it ended up as a bit of a stringy mess, but this was an ABS one from later on, and that looks a lot better than it did initially. Both the carbon filled materials that I printed, this is only one of the little parts. There are some more bits on there that were also printed out of this. And the carbon filled hips, these both printed really, really nicely. I mean, this one's not the best, a bit of too much over extrusion, but this is a really good example of the high quality print that you can expect from this hot end. I mean, this printed at, I think it's 260 degrees Celsius, and it looks absolutely flawless. So both the carbon filled materials that I print with, the carbon filled PETG and the carbon filled hips, both printed really nicely. But in some cases, the exterior finish was really not very good. And that wasn't particularly isolated to the carbon filled materials either. It was mostly down to the settings. So Dyze Design suggests a really wide extrusion width. So for a 0.4 nozzle, I believe the minimum extrusion width they suggest is 0.6 millimeters. Now, I believe the reason for this is that they have designed the nozzle so that you have a small hole, the 0.4, and then a nice wide part of the nozzle next to it, which means as you get extra material out, the nozzle can kind of smooth that down onto the layer below, which, as it's kind of an industrial component, will help with component strength because you get really good layer adhesion because of that really wide line width. However, because of that same line width, the walls tend to be a little bit wobbly. The further you get from your nozzle by increasing your extrusion width, the less control you have over that exterior part of the filament, and it just ends up with a kind of rough surface wall rather than the really smooth ones that you might be expecting from your E3D V6 with a kind of 100 to 110% extrusion width ratio. There were no real problems with actually printing materials. I mean, everything printed without a hitch, even the TPU. So if you want to get this for printing pretty much any material, then I'm sure it will do it. I'm confident that it will manage that. However, there will be a bit of tuning in, and bear in mind that your settings will probably be quite different to what you'd normally expect, especially if you're going to go with a really large line widths. One of my biggest bugbears with this kit was the lack of any significant part cooling. So, I mean, this is not necessarily the things that other people do and they just neglected it. It seems to be a fairly universal thing that when you order a hot end and extruder, there's no part cooling design included. Now, they do have some designs, such as this one and the one I've got on here. I actually cut it off, it's normally 2 fans. They do have these designs that you can use and get for doing the cooling. However, this design one was particularly difficult to print, especially when you consider you're going to need a fairly high temperature material like ABS or ASA, and the fact that these wall thicknesses are just not very thick. This is the kind of thing that I'd expect to have to buy or get from like an SLS out of nylon or something like that to really have the temperature resistance necessary and also to print the level of detail needed on this particular design. This one is obviously a lot more basic to print, hence I ended up with it, but it just doesn't really cool that well. So for the PLA prints, as I mentioned earlier, it just left a bit of something to be desired. It just wasn't as effective at cooling as you'd hope it would be. However, it is worth considering the design use case for this piece of kit. It's not necessarily designed, well, it's almost certainly not designed for printing PLA, although it can, it's not the best. What it's really for is high-end engineering materials. And in that case, you've got kind of a totally heated enclosure. You don't use part cooling pretty much at all. You just let it cool naturally or after printing once the enclosure cools down. So the fact that there's not much of a cooling design is kind of understandable. It's not necessarily for printing PLA, which needs it the most. It's for high-end engineering materials in high-end applications. On that note, it's worth bearing in mind that I am taking a look at the air-cooled version here. There is a water-cooled version, so if you are looking at implementing this into a really high-temperature heated chamber, you can get a water-cooled hot end, which will help with that. So that's pretty much it for the hot end. I do have a little bit of a wish list though. So while the build quality of this hot end is nearly flawless, there are a couple of things which I think could be improved. The fan, the damping, and the heatsink itself, they seem to be a little more cost effective than performance enhancing. I mean, when you compare it to the tungsten carbide nozzle and the titanium heat break, clearly those have been chosen to enhance performance. Whereas the fan that's small and a little bit noisy, the small rubber bit behind it, and the fairly basic design heatsink all seem cost effective rather than performance enhancing. I would like to see maybe a slightly larger heatsink with a slightly larger fan that's a little bit quieter, and maybe a cooling design that's a little bit more optimized. Secondly, I wish there was a part cooling fan like that, or maybe a proper radial fan which has some decent static pressure, and a part cooling duct included in the kit. Well, either included in the kit or as an option in the kit, or even just something you can buy optionally on the website. It would just be really nice to have the whole kit ready and suitable to print at high quality, so you don't have to rely on some random person's design that may not be very well tested, might not be designed very well, might end up warping and bending and all this kind of stuff. It would be just really nice to have something that is ready to implement, that you know works well and has been tested. I did ask about this. I said, are you considering, or would you consider, selling printed part cooling ducts and radial fans to go alongside your kits? It would be great to make the kit more complete for hobby users. Felipe, the CTO of Dyze Design, said, thanks for this suggestion. Actually, we've not seen this request very often, as cooling the parts reduces the mechanical properties and our clients typically require such properties. However, I'll consider it for our next project, and thanks for pointing it out. So there you go, not necessarily something they're looking into right now, but something they might consider in the future, especially if lots of people start asking about it. The last thing I'd like to see is an option for a larger heat block, so a volcano style heat block if you like. The reason being, when you go up to like a 0.9 nozzle that can do like a 1.4 or 1.6 millimeter line width, you can get a lot of plastic out of that nozzle very quickly, which means you're looking then at limitations based on your volumetric flow rate, and the only way really to improve that we currently know of is to have a longer melt zone. So by extending your heat block slightly further down, you can just get more plastic out of your nozzle quicker. And this was a limitation I came into quite a lot when printing, for example, this vase. This was using the 0.9 nozzle, and you just have to print it really, really slow because this is quite a small heat block, despite the fact that you've got a massive heater, just can't push out enough plastic quick enough because it can't melt it quick enough because the melt zone is too short. So again, I asked to see what they were considering or looking to do in the future. I said, did you consider or are you planning a volcano version of the Hotend with a larger block for higher volumetric flow? Felipe, the CTO of Dyze Design, said, yes, this is something I'm working on. We'd like to offer a new extruder system similar to our Typhoon, but on a smaller scale. This is where we could include the fan shroud and a few more features. So there you go, that fan shroud that would be great for hobby users with a radial cooling fan, and the option of a big volcano block are things they're looking into. So I'm super excited to see what they come out with there. So that's it for the Hotend. Now let's take a look at this beast of an extruder sitting above it. First off with the extruder, let's kick off with the setup. Again, fairly simple, it all comes pre-assembled, so there's not really any assembly to do. However, you do need to design a mount. The extruder body has sets of holes in the side which you can use to mount it, but there's no like standard mount for mounting it to any printer, so you need to design some sort of adapter or conversion block. In this case, I printed one out of ASA that I designed simply to attach to this standard Ender 3 carriage, and it works reasonably well, but the extruder and kind of stepper motor area does get quite warm, so I wouldn't print it out of anything like PLA as it's likely to soften. So just keep your, well, ideally you'd have something like aluminium or steel, probably not steel, be a bit heavy, but a nice little aluminium conversion block that would allow you to have a nice strong rigid mount that doesn't get affected by the temperature of the extruder. As with the kind of cooling duct thing, I do wish they would have some more adaptations for popular hobbyist printers, but I understand again why they wouldn't. There are loads and loads of printers that you could want to use, and a lot of the time it's just going to be unique for every different scenario, and it would take probably a long time to validate a really good mount. So I understand why they haven't, but it would be nice to see more of these kind of, even if they just give you the files to be able to make one yourself, it would be really nice to see. Bear in mind that the stepper motor cable that obviously goes into the stepper motor does seem to be a little bit shorter than the other cables. I mean, I've routed it under here, and perhaps I could go up here to get a bit of extra length, but it does seem to be shorter than the other cables. So for my implementation on the Ender 3, it does limit my Z-axis height because the cables are just not quite long enough. They'd end up going through the build volume in order to get to the extruder, which is not really possible. Looking at the printing capabilities of the extruder, there are two things which I find absolutely critical for an extruder. One, they need to be able to grip the filament, and two, they need to be able to push the filament. So the teeth design on this is really, really superb. It's a little bit different to what you'd normally expect. on like Bondtech gears and the standard like Mark 8 extruder gears, you have kind of hob gears that kind of push in like this, whereas this design seems to be more like 4 little pins that come in. It's strange. You'll be able to see exactly that design on screen. I'll put a little kind of close up if you like. It is very different to what I've seen elsewhere, and it does seem to work exceptionally well. For every filament I printed, I didn't have it slipping once, so really good. In terms of skipping steps, the ability to actually push the filament, again, also really good. Didn't have any problems apart from when I wired it up incorrectly, so for obvious reasons, don't do that. I think this is helped not only by the one, really high gearing ratio, I think it's 5.45 or something to 1, so really high gear ratio, and 2, the coatings on the inside, the ceramic coatings on the inside of the hot end, allow the filament to move in really, really smoothly. One way to kind of test this, although it's not a scientific test, but if you've ever manually fed filament into your extruder, which I'm sure you have to prime the nozzle and all that sort of thing, you really notice the amount of force required to push the filament into this versus, say, a E3D V6 or the standard Ender 3 nozzle or anything like that. Those take a lot of force to push that filament in. Even if it's a fairly high temperature and you're just pushing PLA in, it's quite difficult to push. Whereas this, even for the same nozzle size, it just, as you push it in, it just seems to glide straight through, and gosh, it's really smooth interior. So the force required to do that is lower, so less likely to get skipped steps. And then you've got this really high gear ratio with, it's just really smooth, consistent extrusion that's never skipped a step. Nice. Looking at the build quality and other functions relating to that, we've got the removable hot end. I mentioned this briefly before, and it's just a kind of clip underneath the extruder. It works really well. The only downside is that this knob on the top, which is the very small dial here that you have to turn in order to basically unlock the latch, is quite stiff, and it is also quite small, so it can be quite difficult to grab and turn. Because this kind of grabby handle is right here, there's not much rotation or space to do it. I've not had a problem where I can't ever do it. It's just, it takes a little bit of finagling to get it just right. One slight issue that I did have, and probably the only real issue I had with the extruder, is inserting filament. I did find that I had to make sure that the filament was curved in a specific way and put in from the front in kind of that direction, just to make sure that it aligns all the way through the extruder. Otherwise it tended to catch on something on the inside. Now, they do have, Dyze Design have a QC process to make sure that this doesn't happen, and it should always go through. However, I disassembled my extruder as soon as I got it, so I think that's probably why it now doesn't line up as well anymore. What I probably should do is disassemble it and use a piece of filament in there to make sure it's all nicely lined up, and then tighten it down. So probably my fault, but just being aware, if you do have that, then maybe consider not disassembling it as soon as you get it and just use it. One thing that does work really well in terms of loading and unloading is the spring and catch. So on nearly every extruder, you have a kind of tensioning spring to hold the two gears together and to grip the filament, which obviously you still have here with this latch on the front. However, what you also have here is a little locking catch at the back. So you kind of pinch it with the locking catch and the spring, and it holds it all in place, which basically holds the gears apart, so it's not gripping the filament, which makes it really easy to load and unload filament. And then when you're done, you just do another little pinch and it comes off, and then is back in the normal gripping state. That feature is super useful, and I'd quite like to see it on more extruders. It's really helpful for when you're manually loading and unloading filament. The heatsink between the extruder and the stepper motor seems to be just about sufficient. The whole setup does get quite warm, as I mentioned earlier, so for your mount, make sure it's not printed out of PLA because it will probably soften. So yep, just about sufficient to make sure that nothing gets too hot either way. The small steel coupling on the top to hold your PTFE tube is really nice, really sturdy, holds the PTFE tube nice and well, but you will see I've cut mine here, and that's pretty much for only one reason: to be able to hold the filament and direct it in because of my slightly messed up filament loading path because I disassembled my extruder. So yeah, works really well. Again, this is how you would do your balance setup, and you can obviously put a connector on the bottom as well and go to the hot end. In terms of the overall build quality and feel and durability, or expected durability if you like, it's all metallic components. So this thing, I'm sure, is going to print for thousands and thousands of hours before you get any failures in any way. It's just, everything's really well made. There's no like errors or burrs or anything like that. It's really well polished, really well designed, really well manufactured. So what's my wish list for the extruder? Well, firstly, I wish there was some slightly better cable management. As you can see here, I've basically like zip tied all these loose cables to the PTFE tube, and that just doesn't seem like a particularly ideal scenario. Maybe it'd be nice if there was some clip on the extruder or something to just mount and manage the cables a little bit better. I think I've done a kind of average job here, but there's no strain relief or anything like that. You could argue that's part of the kind of the printed design and the etch carriage design, but I think it would be nice to have something on that extruder that can help manage those cables. Another little thing I'd like to see is some pre-made design for inductive probes or other sensors, and the part cooling mounting to it. It's just one of those things that I really feel a lot of manufacturers, not just Dyze Design, could improve the kind of usability and take up of custom designs like this by having some little printed parts that you can pre-design and sit nicely, well positioned with dimensions and stuff. Like, it'd just be nice to see some additional little accessories that go with it to enhance the capabilities without having to put loads of effort in as soon as you get it. And lastly, I would prefer if the cables were a little bit longer. Again, not a major thing. For most implementations, you can probably just extend the cables or anything like that. But for people that just want to have a kit and build it into the printer, it'd be quite nice to have a bit of extra cable length to be able to do that. So that pretty much covers it for the kind of technical review aspects of the hot-ending extruder. However, I do think we need to also talk about cost. This hot-ending extruder are expensive. There's no getting around that. However, they do also have a really big feature set. By that I mean they can do a lot of stuff that not necessarily a lot of other things can do. For example, you might want to compare the Dyze Pro, the kind of hot end section, to stuff you can get from E3D. Now, E3D don't sell an assembled hot end that has this capability, but I went through all their parts lists and basically selected a whole load of stuff that you could assemble into a hot end to get as close to this as possible. And that came to around £190, which is £70 more than the Hotend Pro. So yes, £120 is expensive for a hot end, but it is also a lot less than £190. The Dyze extruder, as far as I can tell, doesn't really have much of a direct competitor. Again, let's take a look at E3D as an example. You've got the Titan, Titan Aero, and I think still Titan Aqua. Do they still do that? But the bodies of all these are pretty much still the same. They're all based on a plastic design, which is fine. It's fairly cost effective and it works fairly well for doing most of your PLAs, ABS and that sort of thing. However, this is a totally all metal design. There's just no way that a plastic body is going to last as long as an all metal one, especially if you're doing it in a high temperature chamber. It's just not going to work. So I don't know of any extruder that is comparable to this one, so it's difficult to compare price. So I'll allow you to decide, well, it's your decision anyway, but I'll let you make up your mind whether the price for that extruder is worth it for that feature set. Personally, I think it's fairly, actually not that bad. So what do I recommend then? What is this good for? Who should be buying this and who shouldn't bother? Well, if you're printing PLA all of the time, I just wouldn't buy it. I don't recommend it, I don't suggest it, it's just no point. I don't think there's any reason to spend this much on a hot end and extruder for printing PLA. There are loads of super low cost options that can give you amazing results, and this is not going to do any better than that. So it's just not worth it. However, there are a lot more materials than just PLA. If you want to print flexibles, ABS, carbon field materials, other more different these are the same, but other more different carbon field materials, then this is going to be an absolutely fantastic kit for that. If you're printing anything that's upwards of 230 degrees C all the way up to 500 C, expensive materials in an enclosure or anything like that, absolutely brilliant. Definitely would recommend. So what if you're kind of a flip-flopper? What if some days you're doing nylon and polycarbonates and on other days you're doing PLA? Well, one of the problems with printing the two materials at those two extremes is that you get kind of a mixing in the hot end. You can't melt the nylon through PLA temperatures, and PLA goes all kind of weird and funny once you get up to really high printing temperatures. So ideally you just want something different for both, which is why a hot swappable hot end is fantastic to do that. Because you can have one to do your high temperature materials, and then if one day you want to just print PLA, you can take that one out. It's like a 30-second job, and just put the other one in. If a lot of the time you're printing things like PETG, ABS and ASA in that kind of temperature range without any hardened materials, then I think it's a bit more of a difficult decision to determine whether this is worth your while. It's not necessarily designed to be optimized for those temperatures or for soft filaments. So do you really need this kind of expense and cost into your hot end extruder to be able to print those materials? I'm going to leave that one totally down to you. What I can tell you is that I don't think you will be disappointed with the performance of this kit if you do choose to buy it. As for the extruder, I'd like to argue that if you're going to get the hot end, you might as well get the extruder as well. However, around £150 is quite difficult to just say, well, just buy it. So do you really need that hot swap feature? Do you really need the capabilities that it has? Is it really worthwhile for you? I'm going to have to leave that one down to you. It's quite a difficult decision, but again, what I will say is I've been very impressed with its performance across a whole range of materials, so it is quite good. So that's pretty much it for my review of the Dyze Extruder Pro and Dyze Hotend Pro from Dyze Design. Now, obviously one thing I've mentioned all the way through is that it is quite expensive, so you can use the code PROSERIES at checkout at Dyze Design for any Pro Series product to get 10% off and free shipping, which hopefully should help you guys in Europe as well. Thank you, of course, to Dyze Design for providing the whole kit for me to review. It's definitely going to be going on this beast of a printer now that I've finished with this review, and we'll be doing some more big, impressive, high temperature, super hard filaments on that. Super looking forward to that. Thank you very much to my Patreon supporters for their ongoing support. If you want to join them in supporting the channel, there's a link for my Patreon account in the description below. Thank you very much for watching. Don't forget to like and subscribe. Hit that notification bell if you want to get notified. Follow me on Twitter and Instagram for more behind the scenes and other catch-up stuff like that. And I will see you in the next one.